Denial of service and distributed denial of service attacks attempt to consume all of the resources that a computer or a network makes available to legitimate clients. And these are a big, big issue because they can disrupt the entire operation of a business. In most cases, what we see is an attacker who's not actually launching the denial of service attack himself. What he's done is, through the use of malware, he has installed software on each of these machines. Now, these are usually infected machines that establish a command and control connection back to his computer, the attacker's that is, and then that attacker at any given time can issue the command to launch this denial of service attack against a specific target. Now, at this point, the target has multiple requests coming from multiple users. Now, these users often will spoof their source address. And so by spoofing that source address, we don't know really who to reply back to. When we reply back to the address, nobody ever responds. A good example of that is the TCP/IP SYN flood attack. In a TCP/IP SYN flood attack, the spoofed addresses start the SYN process. When the server sends the SYN ACK, nobody replies back, and eventually all those resources, those valuable resources, are gone. Now, there are other types of denial of service attacks. One of them is known as the ping of death. And again, the idea behind this is to consume resources or alternatively crash the resource. When we have a ping of death, what happens is the attacker is going to create a fragment. And they're going to set the fragment offset value that's in the IP header to a value that indicates that the size of this packet is more than 65,536 bytes. 65,536 number is the largest size that a packet can be, and that's defined by the IP protocol. There's just no way around it. So what happens is whenever a vulnerable machine gets this type of fragment, it tries to set up buffers to accommodate that packet size, and then all of a sudden it's got no more resources left because it's allocated all this buffer space to a packet that has that fragment offset set to a large size, but it's really not that big. Again, this is just another example of a denial of service attack that can be launched. Now, today, most of our systems are patched against the ping of death. We don't generally see that happening anymore, but it is good to understand that it's a possibility. It is something that could happen. So we want to make sure that we just understand that method of attack. We kind of use that to understand how denial of service attacks work. But there are other protocols that are used for denial of service other than ICMP. Some other examples would be ICMP or UDP Floods. And the idea of those types of attacks is that they can just simply flood out a network, slowing it down, causing the network operations to kind of screech to a halt. Now, one thing that's typically involved in attack of this sort is a botnet. And we saw that example of a attacker using a command and controls connection to attack a destination. And that's usually how botnets function. Botnet operator infects these computers. They become zombie computers at that point, and the code that allows them to be controlled is self-propagating. It's a malware, basically. And of course, when instructions are sent by that command and control server, those bots do exactly what it says. Now, this kind of leads us into the thought that this denial of service is not necessarily going to be seen from a single host to a single target. What could happen is we could have what's known as a distributed denial of service attack. A DDoS is an attack where it targets a website or a server, but the source is distributed, perhaps through a botnet, across the internet, basically. And the problem with this is it makes it real hard to protect against these types of issues. There is quite a bit of detail in Cisco's annual security report about DDoS attacks. They've spent quite a bit of time there highlighting the attack surface there that we see. But what we need to understand is that DOS attacks don't necessarily come in one way, shape, or form. The whole concept of a DOS, to consume resources, to crash computers, that stands true, but the method of implementing that DOS can change. We saw it change from the TCP SYN flood to the ping of death to UDP floods. Even email spammers are using distributed denial of service attacks to basically retaliate against organizations that they think are preventing them from stealing or generating revenue from people. We are seeing a trend in cyber criminals making use of cloud-based computing services like Amazon and such to launch their denial of service attacks and distributed denial of service attacks. One example of this type of DDoS campaign that caused a lot of problems, significant disruption and damage, as well as financial loss. One of those was called Dark Soul. This targeted devices in March of 2013. It involved a malware that destroyed data on a hard drive. Another type of denial of service attack that we are seeing that again is making use of cloud-based services to propagate themselves and to distribute themselves is ransomware. And so attackers today have moved away from that botnet-driven denial of service, and they're using ransomware to spread their malware and to encrypt the contents of one's hard drive, and then they are forcing users to pay a ransom to retrieve the encryption key. Now that ransomware, a recent one was dubbed CryptoLocker, and it would encrypt your files. It would use 2048-bit RSA key pair and AES 256, so it couldn't be broken. It was a rather sophisticated attack, and it would spread itself through mapped drives, and it would spread itself through the network that way. So you may be connected to a network drive, and the ransomware would encrypt what was on that network drive, and it would actually affect other users, even though one user was the one that got infected. And you would get a pop-up or a web page redirect that would have you pay a ransom within a certain amount of time. And if you didn't pay it in a certain amount of time, then the private key was going to be deleted from that command and control server. And if that happened, then all of your files would be lost. So if you had a good backup scheme, you'd be okay. But if not, then a lot of people lost a lot of data based on those type of attacks. So these are just some examples of denial of service attacks and the havoc that they can wreak on a network.